Hi folks, welcome to CS61B. This is a second semester programming class that builds on top of CS61A at Berkeley. You don't have to have taken that class in order to use the materials from this class, but I think you do need to have a solid programming background. And so I'm going to start this story by referring back to what hopefully you know from 61A or some other class. One of the first lessons you learn in computer science is that programming is done in layers of abstraction. That is, you have some basic pieces, some basic abstractions that you can use to build your software. Now, the software you build is itself an abstraction that could then be used by other layers of abstraction. And in that way, you can build like pretty big stuff, right? Without caring what's happening at the very bottom. So I'm going to pick as a particular starting point a list in Python. And in 61A, or if you've seen Python before, you know that it's possible to create a list using syntax that looks something like this. X equals 3, 4, 5. And then I can append to that list. Now I can expect that this list has certain behaviors, that after I do this append, there's a 6 at the end. And I'm not really thinking about how does the list work. I can actually go to the code that implements the list. Here, I'm not going to click it, but you can look at this code later if you're curious and see. And what you'll see is that it's several thousand lines of code that make a list possible. Now, at some point, someone had to think really carefully about exactly how they wanted to implement this list. And there's a lot of trade-offs and a lot of richness. But when you use a list, you don't think about those thousands of lines of code or any of the decisions that were challenging for them to make. You just use the list, and hopefully it does what you expect. So in 61B, we're going to start there. We're going to be thinking about the Python list and how it works. Okay, so what's this picture? This is a classic idea called Plato's allegory of the cave. I'm going to show this a few times in class. And in this story, here are the cave dwellers. These are the least enlightened folks in this picture. They have a reality in front of them. They see these shadows on the wall, and they see a scene playing out before them. What they don't know is that behind the wall, there are these monks, and they're manipulating the shadows on the wall and generating the reality that's seen by the people in the cave. So too is it with the user of a list. I say x equals 3, 4, 5, x append 6, and behind the scenes, there's something happening. I don't know exactly what's going on. And the reality that's presented to me is self-consistent, but I don't really see the true nature of that reality. So in 61B, in the first 4 weeks, that's going to be us. We're going to be building a list, not a Python list, but a Java list. And I'll talk more about Java in a bit. We're going to be manipulating at a lower level some more basic abstractions that will make it possible for someone else to have a list. Now, I should note that in the classic story of Plato's allegory of the cave, the idea is that you should seek enlightenment. You should go find the true nature of reality. But often as a programmer, we don't want that. We want to deliberately obscure the true reality from us. We don't think about it. It's behind layers of abstraction. But for us, the beginning of 61B is going to be thinking about peeling back this first layer to know, well, someone has to build the list. So when they built it, how did they do it? So in particular, what we're going to do in the first 4 weeks is we're going to explore 2 radically different approaches to building a list. One will be based on something called an array, and something else will be, the other approach will be based on a linked list. Now, along the way, as we build out our list implementations in the first 4 weeks, we're also going to explore some different tools and techniques that are more industrial strength than the more ad hoc programming you might have learned earlier. Now, zooming out from those first 4 weeks, if we think about what 61B is really about, it's about 2 things. One is about writing code that runs efficiently, so you let it run, and it doesn't use too much space or time. And 2 key ideas there are using the right algorithms and the right data structures. More about that later. The other thing we're going to learn is how to write code efficiently. So how to use our time well to write code fast. So we want to learn how to design, build, test, and debug large programs, including programs that implement and cleverly utilize data structures. That's a big theme in the class. And we're also going to learn how to use some programming tools. So we're going to be talking about Git. We'll talk a bit about large language models, which are extremely important, especially in big software. We're going to use them a little less than you would expect in like a real software design environment because we want to build those basic skills. But we are going to talk about LLMs here and there. But again, this class is about building the foundational skills, so we don't want to get too reliant on them in this class. We'll use IntelliJ, which is a tool for helping us write software in Java. It's not 100% required to use, but we strongly recommend it. JUnit, which is a testing framework. Actually, we'll also be using something built on top of JUnit called Google Truth. And we'll also learn some various command line tools here and there. Now, in this class, I'm assuming you have a solid foundation in programming fundamentals. So that includes the idea of object-oriented programming. So you should have seen that. You should be very comfortable with the notion of recursion, code that, like functions that can call themselves, lists, and trees. So those are things that would be nice to have seen. It's not absolutely imperative, but I think you'll get more out of the class and be able to move more quickly. Because especially once we get to the third lecture of this series of lectures in this class, their recursion and lists become really important really fast. Now in this course, we're going to use Java. The reason we're using that instead of what you might have seen if you're a Berkeley student taking 61A, one reason is that the code you write is much faster than Python, so Java code tends to run much faster. It is possible to write fast Python code as well, but Java, generally speaking, it is easier to write code that's fast. Two, it's going to include a bunch of different programming language features that I really like that are not present in Python, like static typing and arrays and subtype polymorphism. And we'll be seeing these ideas throughout the first 4 weeks of the class. And those are important ideas that are a bit different than how we think about programming in Python, that allow us to build faster software that is also easier to maintain. Static typing in particular, I'm a big fan, and I'll tell you what that is later today. It's also an extremely popular language. It's one of the most popular languages. It's a little old-fashioned, Java. So I could easily have done this class in like Go or Kotlin. Those would be reasonable alternatives. But Java is such a popular language and it's well established that I'm going to use that. But you know, the language choice isn't actually that important, other than certain features like these that I really want you to see. If you think about the progression of the lower division computer science courses at Berkeley, at least at the present day, in 61A, you're doing, I would say, these higher level languages. So we have Python, Scheme, SQL. Java's a bit lower level. And then if you go on to 61C, that's an even lower level language where you'll be talking about C and assembly code. Other reasons you might be interested in 61B beyond this notion of becoming a strong programmer and knowing how lists work and that sort of thing, is that, well, we cover a lot of the most popular topics for job interview questions in software engineering. So often if you go to a job interview, people will ask you questions about, say, Dijkstra's algorithm or binary search trees or quicksort. Those are just the bread and butter of the job interview landscape. It almost feels a little bit like in the old days, whenever you wanted to be a distinguished gentleman, you had to learn Greek and Latin and that sort of thing. And these days, there's a set of topics, at least at the current day, listed here and some more that we're going to cover throughout the class. We'll talk about some really cool math in the class that's really handy, like the idea of asymptotic analysis of algorithms. So this would be like your big O and big theta notation, a really useful tool. The idea of arrays that can resize. I'll tell you more about that, and others here that I'm not going to list off. And then once you're done, what I really want you to have is the confident sense that you could build any software. It might not be the most beautiful thing, but you should be able to get there. You can keep your software from collapsing in on itself like a black hole. That's what I want to get you by the end of the class. Okay, so welcome to 61B, and let's start talking about some other stuff.